Hello. Can everyone hear me? Hello. Can everyone hear me? All right, I'll go ahead and begin in just a couple minutes here. Wait for a few other people to join, and then we'll begin. Awesome. Okay, I'll go ahead and begin. So hello, everyone. My name is Alex Martinez. I'll be your, session lead for the Machine Learning Nanodegree program. Oh yeah, let's do an audio check. Can you guys all hear me? All right. Yeah, so if you wish to chat with me, I'll be following the chat here on the YouTube Live. Otherwise, if you have any questions outside of this, please send me a message either directly or in the chat on Slack. Awesome. So today it'll be really short. This was supposed to have been done last week, but last week I was sick, so I'm just trying to catch up here. This will basically be mostly an introduction as to what to expect of the program. I also saw that with regards to the schedule, there were a lot of people that had already begun. So great job, all of you. There were also some people that were, I guess, still slow to starting up. So for those people, I'll be holding this. At the very end of this, I will go ahead and do roll call as part of the requirements for the webinars. I have to see who attended each of these. So at the very end, just please, or I guess at any point, just put it in the chat here, and I'll write you in afterwards. I think that'd be the best way to go about it. So yeah, so the first 20 minutes, I'll just talk about what to expect for the class. The next 20 minutes, I'll give an overview of what machine learning is, and we'll end it by going through the Titanic Survivors Data tutorial. So my name is Alex Martinez. I was born and raised in Southern California. I started my career as a software engineer at Ticketmaster, and I worked there for several years before switching over to becoming a freelancer for machine learning engineering. And I guess about a year and a half ago now, I was picked up by Udacity to start teaching classes. This is the second time I've taught machine learning for them. I've also taught business analysis, amongst other things for them. With regards to this class, what you guys can expect is every week we'll be holding a webinar. We'll be covering lectures, discussions, and activities to reinforce and support your online learning, as well as check-ins, just to make sure that everyone's keeping on track, also answering any questions you guys have. The first 6 or 7 weeks or so is very planned out with regards to what material needs to be covered. But after that, it's very open-ended based off of what you guys need. So as we get to that point, I can go ahead and work with you guys and develop the webinars to keep pace with you. Outside of sessions, you guys are expected to dedicate roughly 10 to 15 hours of learning, researching, reading, and projects. In addition, with each of you guys, I need to schedule a 30-minute one-on-one just to see how you're doing, answer any questions you have, and making sure that you're not running into any setbacks. And finally, if you have any questions, feel free to reach out to me in Slack. Otherwise, if I am unable to answer any of your questions, I can go ahead and elevate it to somebody who may be able to do so. Regarding the weekly webinars, they'll be every Thursday from 7 p.m. to 8 p.m. Regarding the one-on-ones, please schedule those with me if you haven't already. The best times for me regarding those are any day of the week, usually in the evening after 6 p.m. I prefer between 6 p.m. or 10 p.m., just a 30-minute time set for us to just talk. And also, I will be holding office hours every Wednesday from 7 p.m. to 8 p.m. If you're unable to make these weekly webinars, the videos will be hosted on YouTube, and I will be posting the videos on Slack afterwards. However, if you have any questions regarding the material that's being covered, I highly advise that you show up to these so I can answer your questions here. So is there any questions so far? And again, if you have any questions, please post them down in the chat for the on YouTube. The office hours will be held via Slack. Yes, I'll be making use of the Machine Learning at a Degree channel. Yeah, one of the things that you can normally do via Slack is send messages to everyone to notify you as to what's going on. Unfortunately, I think they removed that at everyone call. So I'll just try to message you guys whenever I can, just to let you know. But yeah, every Wednesday for office hours, every Thursday for the online webinars, all on Slack. The one-on-ones initially will be Slack calls, but we can look into other forms of communication if you prefer those. Okay. So if there's no other questions regarding that, I'll go ahead and move on with that. So just going into more detail regarding the one-on-one sessions here. Let me go ahead and drag this over. So when we actually do our one-on-ones, I'll have to go through a sort of questionnaire with you guys the first time around. And let me go ahead and drag it over to this window just so you guys can see it. 1 second here. There we go. So it looks something along the lines of this. Essentially, it'll just be gathering information regarding what you guys expect to get out of this course, what you guys' background already is. It'll help give me information that I can use to help better plan out these online webinars and give you the information you want, as well as provide you with any resources that you would need to get the most out of this program. So really scheduling out these one-on-ones with me will be very beneficial for you, and I'll try to make it as beneficial as possible for you. The more information you provide to me, the more I'll be able to assist you. So if you haven't done that already, please schedule that with me after this. All right, so with that, I'm going to go ahead and start moving on to the introduction to machine learning. With regards to what I can help you with here, I can help out with any questions you have regarding the machine learning concepts, how machine learning is used in production, with regards to the real world applications, as well as providing resources, guidance, and helping you find answers to your questions. I'm really more of an assistance towards the material that's provided by Udacity through the online course. If you have any questions, or if you're not getting anything, feel free to reach out to me and I can try to explain it in a different way. Regarding these sessions, regarding the chat, please be respectful to one another. If you're going to speak, or if you have any advice, please offer and accept meaningful feedback. Always assume the best intentions from others, and work to be done by the end of this course. If you're not able to complete everything by the end of the 3 months, they are very lenient with regards to giving you guys extra time for the projects. They usually base the class's completion off of the projects. So if you complete all of the projects, you will graduate from this term. So watching the videos, you don't need to necessarily watch every single video to finish. Just make sure you complete all the projects, make sure you turn them all in, and make sure they're accepted. Regarding the projects themselves, if you haven't ever taken a class with Udacity before, what happens is that there's somebody else, not me, who looks through your projects and reviews them and provides feedback. The feedback that they provide can take anywhere from, the fastest I've seen it has been like 10 minutes. The longest has been a couple days before they send you feedback, at which point you need to fix the project and then resubmit it. My best advice is they're very on top of sending you the feedback. Just once you get it, redo it based off of what they're requesting and then resubmit it. It's not the same person that grades the project every single time either. So what may be okay with one grader may be different with another grader. If you feel it's okay, probably just reword it and then resubmit it, and another grader might be more lenient towards it. So if you don't get it the first time, just keep resubmitting. And I believe you have as many resubmits as you want with regards to submitting the projects, just so long as you complete them before the end of the deadline. Are there any questions regarding the material? Okay, I'm not seeing anything, so I'm going to go ahead and move on. So regarding machine learning overall, it's an extremely large field. You may have heard several terms within this field, such as artificial intelligence, data science, deep learning, machine learning. So what I'm going to go through in this section is just sort of breaking down what machine learning actually is and comparing machine learning to traditional programming. In addition, I'll talk about the overall machine learning process flow. I'll talk about some use cases for it, as well as the different types of machine learning. And then I'll be covering some main categories and fundamental concepts, talking about some of the challenges that the field of machine learning has faced and is currently facing. And then finally, how to cover machine learning, or how for you to best approach it. So with regards to the fields of machine learning is actually a subset of the larger field of artificial intelligence. And whenever you hear the term deep learning is actually a subset of machine learning. Now, there's also data science that's talked about as well. Machine learning is actually a subset of data science, and data science is somewhat of a subset of artificial intelligence. So it's just kind of circles within circles within circles here. Here are a few quotes that I thought that encapsulated what machine learning is. So machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. And a computer program is said to learn from an experience, E, with respect to some class of tasks, T, and performance measure, P, if its performance at tasks in T, as measured by P, improves with experience, E. So what that's basically saying is whenever you have a task, and the task has some way of measuring it, whether that's a yes or a no, or numerically, or different categories, then you can take each of those experiences, build a model from them, and then train that model based off of the performance. And again, it's okay if you don't understand that right now. We'll go into that in more detail as we walk through the flow of how machine learning actually works. But first, explaining the difference between traditional programming and machine learning. So traditional programming is, essentially where you have data, you have a program, the computer computes the data using the program, and it outputs a result, which is what you tend to use. Differentiate that from machine learning, which is where it takes in the data and it takes in the results. It then computes those and generates a program. The program is sometimes human readable, depending on the complexity of it. Sometimes it may be very hard for us as people to understand how exactly that the machine learning algorithm works. But that's essentially what we're going to be doing here, is creating a program or creating some code that can generate an algorithm from this data and the results. And if I'm going too fast, please let me know in the chat. Also, if you have any questions, just feel free to please post them. But continuing on with the machine learning process flow, generally what happens is you have your data, which you can collect from various sources. Sometimes a huge part of the task itself is collecting the data. With regards to machine learning, though, we'll assume that the data has already been provided. The next step is cleaning the data and transforming it and normalizing it such that it can be used within a model, and at the same time minimizing any error that might inherently exist within the data itself. So that's handling outliers, handling the distribution of the data, handling the formatting of the data, handling data types. All of that happens within the data cleaning and the transformations. The next step is you then build the model and train the model. All right. So in order to do that, what you do is you take a subset of the data, you use a subset of the data for training, and you use another subset of the data for testing, which is what the upper portion is for the testing. So after you've built your model and trained it on the training data, you then validate and test that model using the test data. And based off of how the model performs, you then use that result to better fine-tune the model, and you keep looping that until the model has reached a certain threshold based off of whether you're measuring accuracy or some other form of measurement before finally deploying the model once it's good enough. So this right here, the flow, is actually extremely powerful and has a lot of applications that you see in everyday life. With regards to what it's good for, though, it's good for any task that requires a lot of hand tuning or a long list of rules, such as a spam filter. Machine learning is great for complex problems for which there is no good solution at all using traditional programming, such as speech recognition, or in a lot of cases, image recognition or video analysis. It's also great in fluctuating environments where there's constantly new data being generated. And it's also great for getting insights about complex problems and large amounts of data. With regards to machine learning itself, you can think that this field is sort of subdivided into 3 more fields. Those are supervised learning, unsupervised learning, and reinforcement learning. With regards to supervised learning is where you have all of your data, but the data itself has the results with it. So for example, let's say that you have a bunch of pictures. Let's say in this bottom diagram here, you have a bunch of pictures and they're labeled as either bananas or apples. So you train your model based off of this training set, and you pass it through the learning algorithm, and then you pass it a new image and you ask it, what is this? So if you pass it in the image here to the right, it should output banana, because it learned from the other images that were labeled as bananas that that is what are the properties of a banana. So supervised learning is taking in some training data, which is the set of inputs, the images, plus the correct outputs, which are the labels, whether that's a picture of a banana with the label of a banana attached to it, or a picture of an apple with the label of an apple attached to it, or something more complex. And then the model learns by comparing the predicted output with the correct solution. So what it's doing is it'll at first randomly generate results based off of if it's an apple or banana. So the first runs, it will be completely off for the most part, unless you're extremely lucky. And then it will compare the results that it generated based off of the actual results. So let's say for this banana over here to the far right, it predicts it as apple. It then gets the actual answer, which is banana. It will then take that information, that error, and it will go back, retrain itself, and keep retraining itself until it does better. So it uses this error to modify the model accordingly. And then finally, once it's all done with your training data, it will then use this new model to predict new, unseen, unlabeled data, such as pictures of fruits that have been passed in which you have not told the machine what is what, and it will be able to predict with pretty good accuracy what the labels ought to be. Supervised learning can be kind of broken down itself into two larger problems, which are regression and classification. Regression problems tend to have a continuous valued output. So, for example, if you're trying to predict someone's age based off of how they look, or if you're trying to predict the value of housing in a certain city or area in a dollar amount, or if you're trying to predict, let's say you're working the stock markets, what the value of the stock will be in a few days. Those are all regression problems because you're looking for a numerical output. Compare that with a classification problem where you have a discrete valued output, which is to say that there is a limited number of possibilities. As an example would be the fruit example we just did in the previous slide, apples versus bananas. It's either an apple, which you could label as a 0, or a banana, which is a 1. And there's no in between. So some examples of this would be whether determining somebody's sick or not based off of incoming data, determining whether or not somebody has cancer, or given some images, determining whether or not the images of a cat or a dog or an elephant. Or with a more complex example, you'd like a piece of software to examine individual accounts and decide for each account if it has been hacked or compromised, a 0 if it's not hacked, or a 1 if it has been hacked. Are there any questions on supervised learning? Okay. Moving on to unsupervised learning. So unsupervised learning is the exact same problem as before. Let's say we're passing all the images with no labels. We were not told what was a banana or what was an apple. This system will then just look at these images. It will try to find patterns within the images, and based off of how many patterns it finds, it will then divide the images based off of what it assumes the patterns are. So it'll say, hey, this thing right here, this has a pretty round shape. I'll group it with other round shapes. Hey, this yellow thing over here, it's yellow versus the red thing, so we'll separate it yellow versus red. Internally, it determines the best way to separate the objects, and then it separates them and classifies them on its own based off of that. So this would be considered a clustering model. And this is most commonly used to explore the data to find hidden structures, and it's used with clustering, visualization of data, anomaly detection, and association learning rule. You could think of anomaly detection as just finding outliers. So if we find that everything meets a certain norm, but there's a few things that are different, that would be anomaly detection. With regards to where unsupervised learning is useful, it's useful in a lot of cases where we don't know patterns in advance, or we don't know the labels for data in advance. Some real-world examples would be social network analysis. So given a set of news articles found on the web, we can group them into sets of articles based off of the text. Or given market segmentation, given a database of customer data, we can automatically discover market segments and group customers into different market segments. Or another use case would be astronomical data. Just based off of different incoming data, can we group different clusters of stars together and say that they are one group versus another group? Are there any questions on unsupervised learning? Fraud detection. So the question that's being asked is, could fraud detection be considered unsupervised learning? So fraud detection, based off of how you set it up, it can be considered unsupervised learning if you don't have any labeled data and you're just looking for something that is unordinary. So that'd be a different form of anomaly detection. However, if you have a large enough data set where you have a history where you have labeled data that's considered fraudulent versus non-fraudulent, you could technically also do that with supervised learning. But unsupervised learning in and of itself will only group data together. It in and of itself doesn't really classify. It doesn't give labels. You yourself have to go through and figure out how it's clustering things together. So if you can build the algorithm on top of unsupervised learning, use anomaly detection to break apart what is normal behavior and what is, unordinary behavior, and then you could then analyze that subset and see whether or not it's fraudulent. So in that sense, yes, it could very much be used for fraud detection. Okay. All right. Any other questions? Or I hope I answered your question well enough. All right. So I'm going to go ahead and move forward with reinforcement learning. So reinforcement learning is very similar to supervised learning. Only in this case, instead of telling it a label as to what is, an apple or banana, instead what you're doing is you provide it with several actions that it can do within a world. And we call the world the environment, and we call the current state, we call the current state that the algorithm is in the state. So given its current state, it performs an action, and based off of that action, all the algorithm provides it with is either a reward or a penalty for its action and the new state that it's in. And so the only feedback you can give to the model is, hey, let's say using the example at the bottom here, you have a robot that's trying to determine between a bucket or fire. And so the first time it makes a random decision between going left towards the fire or right towards the bucket. It goes left towards the fire. That's its action, is that it went left. Its new state is now it's close to the fire. The model itself provides it with a negative reward. Hey, minus 50 points, you did a bad thing. The model then trains itself and it says, okay, going towards this is bad. And then it tries to find out different actions. And based off of the state and the action, try to assign an internal point to performing that action within that state or a similar state to it. I'm finding examples here. So some examples of this would be self-driving cars. So if a self-driving car, a lot of times when it's first being trained, it doesn't know what's a good action, what's a bad action. What you do is that you provide it with a reward system. So it starts learning based off of its interactions with the world as to what are good actions, what are bad actions. And then over time, as you train it, it will begin correlating like actions together and providing those with similar rewards such that it will improve over time. Let's see here. Are there any questions regarding reinforcement learning? Okay, so if there's no questions, I'm going to go ahead and move on. So I've told you everything that machine learning can do, but even with how powerful it is, there's still a lot of drawbacks that it has. For example, machine learning in and of itself is very dependent upon the data that it's provided with. If you provide the model with bad data, I'm sorry, we have some questions. Yes, so some applications, yes. So when with regards, so some more applications, Chris brought up some good, some extra points, like playing chess. It was recently applied to video games such as Dota, StarCraft. Essentially, being any environment where you have a set of actions that you can provide. So with chess, there was the whole or with Go, there was the whole thing where they trained a bot called AlphaGo to beat the best players in the world. And essentially, there were two that were developed. There was AlphaGo, and there was also AlphaZero, I believe it was called. AlphaGo was trained using data from previous matches, whereas AlphaZero played itself a bunch of times. And based off of playing itself, and given the basic rules of the game and given a reward system based off of the rules of the game, it trained itself to beat the best players in the world. It's also very useful if you with regards to robotics, because robotics is also very much, hey, this is my current state. What should I take as an action? Should I provide more power to motors? Should I provide less power to motors? Should I turn a servo so much? It can be used with regards to teaching it to play music like somebody. So let's say that you have it start playing music, and you have it start trying to you give it basically its actions, and then you give it a reward system based off of, let's say, how Beethoven plays, or based off of how Bach plays. I believe Google did something very similar to this recently with one of their. You know how Google does the daily things where if you click on the words Google on the Google.com, it shows different links. One of the links recently was where you input music, and then it converts that music to sound like something Bach would play. That was using a variation of reinforcement learning. So reinforcement learning in and of itself is extremely powerful. That being said, because the data for reinforcement learning is mostly provided by it playing within the environment, you can try jumpstarting it by playing within the environment yourself and then using that as seeding data, but it still has to play within the world itself to handle all of the outlying states that you may have missed. So going back to the machine learning challenges, these challenges are for supervised learning, unsupervised learning, and reinforcement learning. If you have insufficient quality of or quantity of data, regardless of your model, generally you end up with a bad model. I'm sorry, I'm sorry for skipping ahead like that. I hope that that covered your question. But yeah, also other bad things that can happen is if you are given data that's non-representative of the actual population. So if you have a bad subset of data, that can cause your model to learn incorrectly. Otherwise, if you've not cleaned your data sufficiently, that leads to poor quality data, which will also affect your model in a negative way. And finally, if you provide irrelevant features to your model, it may start trying to associate irrelevant features to the model itself. So as an example here, let's say that you have a model that is trying to learn how to play chess. All right. And as it's making moves in chess, one of the features that you pass in is the color of, let's say you're playing chess on the computer, and let's say you're playing a specific type of chess, like let's say a skinned version of chess. If you pass in all the colors of the different skins of each piece, it may think, oh, if I use this skin on this chessboard, that affects my winning chances versus another skin on the chessboard, when in actuality, that shouldn't affect it at all. That would be like an unnecessary feature. Or I guess as another example, if you're trying to use a supervised learning model and you're trying to see if you're trying to predict a student's grades at the end of a year, and if one of the features you pass in is how many freckles each student has, the number of freckles each student has, at least as far as I know of, doesn't have anything to do with how well a student does in class. But if you're passing that data to the model may think it's relevant. So that goes into feature engineering. Just before you even pass in the data to the model itself, we as humans have to do our best to clean the data for the model. Finally, not only do you have bad data, but you could also have bad algorithms, where you create a model that is too complex or a model that is too simple. Let's see if I have a good example of that here. Yeah, so given this example here, you see in the lower right, there's several figures. So there's the one in the upper left where it's a scatter plot with a line of best fit. All right. In this case, we have a very simple model. It's just y equals ax plus b. Just the formula for a simple line. A bad algorithm would be one where it says, oh, instead of using a simple line, let's try to fit the line using y equals ax to the fourth power plus bx cubed plus cx squared plus dx plus e, where it creates some sort of crazy squiggly line that, while yes, it would fit the training data better, it would be too complicated for what we're actually looking for in this case, which is really just a line of best fit. So when designing your algorithms, you do have to make sure that you're not overcomplicating it, or you have to make sure that you're also not making it too simple. And finally, stepping back, machine learning is about making machines to get better at some task by learning from data instead of having to explicitly code rules. There are many different types of machine learning systems. Once again, we went over supervised learning, unsupervised learning, and reinforcement learning. The system will not perform well if you give it bad data, or if your training set is too small, or if there's too much noise, or if it's polluted with irrelevant features. And finally, your model needs to be neither too simple nor too complex. Are there any other questions so far? All right. So in a nutshell, the entire machine learning process is you clean your data, you split it into a training and testing set, you feed the training set to a learning algorithm, and then you evaluate and tune the model using your testing set. And you rinse and repeat. So data goes into your algorithm, and there's several algorithms listed here that will be gone into more detail later on. And it generates a model. And with regards to evaluating a model, there's several different ways of doing it, which again will be gone over later on. So the question Chris is asking is, machine learning engineering is to pick a good algorithm and find good features to create a good model. In a nutshell, you can think of it like that. A lot of what machine learning is you're given the data and you're given features, and your goal then is to figure out what is the best model to use. So the first question you should always ask is this a supervised learning, unsupervised learning, or reinforcement learning problem? Based off of that, you then have to ask yourself, if it's supervised, is this a regression problem or a classification problem? If it's unsupervised, you have to ask yourself, okay, am I just trying to cluster here? Am I trying to do anomaly detection? What's the goal? And then based off of that, you then have to clean the data accordingly, such that the data itself can be used with the model. And even then, there are a lot of models to choose from, and each model will work, or each algorithm will work differently for a different use case. So a lot of it is really just trying out many models, seeing which one performs best, and then trying to fine tune that model. So yeah, based off of what you said, Chris, I'd say that that encompasses it pretty accurately. All right. So right here is a sort of larger scale map of different algorithms, different evaluation metrics, and different libraries that you can use within Python. This applies mostly to supervised learning here. This isn't even all of the algorithms, but just to give you a nutshell of just what you can do with it and tools that are available to you. Here's a cheat sheet. And again, each of these topics will be gone over in more detail as we progress through the lessons. Oh, yeah. So another question that Chris is asking is if I could quickly explain the difference between a machine learning engineer and a data scientist. Yes. So you can think of a data scientist as somebody. Let's see if I can go back here to one of the slides that I think would encompass it best. So going back to the machine learning process flow. In addition, so this right here encompasses what a machine learning engineer will tend to look at. A data scientist, in addition to this, like I said, it's a data scientist works on a sort of larger scale. So they also work with the data collection. Um, they Yeah, so essentially they'll look at everything from a larger scale. So in addition to doing what a machine learning engineer does, they also take a look at the data. They provide any data cleaning, perform data engineering, as well as performing a lot of the machine learning tasks that are done as well. And this can be pretty complicated if you look at the entire flow, because if you're dealing with a small amount of data, then it's just a matter of cleaning it. But if you're dealing with a large amount of data, it's about filtering out the data, taking whatever subset you need, trying to find out how to handle this large amount of data to make it work faster. Yeah, I'd say that's definitely it. The scope is bigger for a data scientist. And their work also encompasses a lot more data analysis. Yeah, exactly like what Andrew Ning said. Their work requires a lot more data analysis than what a machine learning engineer would typically do. Does that answer your question? Awesome. Okay. All right. So I've listed some resources here. There's a lot more resources available depending on what you want to do. So you guys already know about Udacity. If you want to look for machine learning projects, Kaggle is a great source because it's a huge collection of data for you to look at. In addition, there's a lot of books out there, such as Hands-on Machine Learning with Scikit-learn and TensorFlow. There's a lot of blogs out there. If you don't follow the machine learning subreddit, I highly recommend you do so. They're always talking about great papers that are going on. In addition, YouTube always has a lot of great videos. I know Andrew Ning posts a lot of videos out there. If you guys also don't follow Siraj, he's another great guy who talks a lot about machine learning in general. I can list more resources in the Slack channel if you guys want. But there's a lot of information out there outside of Udacity that you guys can use to learn more about the field. Okay, so I'll answer any more questions before jumping into the next portion, which will be the Titanic survivors data set. Okay. second here. I'm just getting the project ready. I'll go here. Okay. So if you guys aren't already, if you guys want to follow along, I recommend you go to your Udacity classroom for machine learning. We're going to be going to section 1, machine learning foundations. And we'll be going to lesson 3, which is the introductory practice project. So once again, that's machine learning foundations, lesson 3, introductory practice project. I'm going to viewing lesson. And the first few parts talk about the project overall, as well as the software requirements. And I'll walk through this first project with you guys. So in this practice project, you will create a decision function that will attempt to predict the survival outcomes for the 1912 Titanic disaster based off of each passenger's features, such as sex and age. You will start with a simple algorithm and increase its complexity until you are able to accurately predict the outcomes for at least 80% of the passengers, sorry about that, in the provided data. You'll be making use of 2 libraries here, NumPy and Pandas. And this section will familiarize you with the submission process for the projects that you'll be completing as part of the nanodegree program. This project is not graded, so don't worry about accuracy or any of that. Just do as well as you can. It's just for a learning experience. Regarding the software requirements, so this will be using Python as the language, as well as NumPy and Pandas, as well as Matplotlib to actually visualize the data. It'll be using Jupyter Notebook. All of this will be hosted right here on Udacity's website. So you don't, if you want to, I highly encourage you to download this, but it's not necessary for this project here. In addition, this version, the Python version that's being used here is Python 3.6, I believe it is. So if you want to follow along, just make sure that you have that same version of Python installed. The project itself is created from 3 files. There's the Jupyter Notebook file called Titanic Survival Exploration. There's the data file, which is the titanicdata.csv. And then there's the code that it's using to actually visualize all the model, which you can find in visuals.py if you want to take a closer look at how that works. So if you go ahead and click on under concepts on the left-hand side, where it says overview, software requirements, project files, and Titanic survival exploration, go ahead and click on number 4, the Titanic survival exploration, and that should open up the worksheet here on Udacity. This right here is a basic Jupyter Notebook. If you guys don't know how it's used, the basic concept is whenever you have it, it's broken up into 2 cells, or several different types of cells. The text cells are called markdown cells, and these other cells are code blocks. So let's go to this first code block and click inside of it such that it's highlighted, and you'll know it's highlighted if it's surrounded by green. In order to run the cell, all you have to do is hit Shift and Enter at the same time, and it will run the cell. You'll know it's being run because it'll have a little asterisk followed by a number right next to the word in, and then the output will be displayed right below it. And again, everything that I'm saying here is written in the text, so I'd highly recommend you read through this as you follow along, as it'll explain all of the instructions in more detail as to what I'm actually doing here. But essentially what this first cell is doing is it's showing us the first 5 rows of the data set, and it's showing us each of the features that we have. So right here, you see we have a passenger ID. We have whether or not somebody survived on the Titanic. A 0 means they did not survive, and a 1 means they did survive. We have a P class, and again, all this information is described right below it, right here in this highlighted section. So we have P class, which as described right here, that designates the socioeconomic class. 1 means upper class, 2 is middle class, 3 is lower class. You have the name of the passenger, which is a string. You have the sex of the passenger, male or female, also a string. You have the age. And this is something that's very important to note here, is that some entries for the age contain NaN. So this data hasn't necessarily been cleaned all that well. And this is something to note because when we're actually working through this project, this will come back to affect our models later on. So do note that some of the ages are not written in. You have the SIB-SP, which is the number of siblings and spouses of the passengers aboard. You have the P-arch, which is the number of parents and children of the passenger aboard. You have the ticket number. You have the fare paid by the passenger. You have the cabin number of the passenger, and you have the port of embarkment, which is whether that's C, Q, or S. So this right here is a supervised learning problem because what we were trying to do is we were trying to predict whether or not the passenger survived. All right. So we're trying to predict whether or not somebody has a 0 or a 1 from this data set. We've already been provided that information, but we want to be able to use that to predict people whose information we don't have. So this is a classification problem underneath supervised learning. So the first thing that we're going to do here is that we are going to clean our data by removing the label, the survived or didn't survive from the data, which is this full data.drop in this next cell. So all I did was I hit Shift Enter on this cell, and then we're displaying the results beneath here after you drop the survived data. So as you can see in the original, we had survived. In the new one, we do not. We just have passenger ID, straight to P class, whereas beforehand, we had passenger ID, survived P class. And this is just so that when we're training our data, it doesn't take into account the label. Because if you're trying to have it predicted, all it will do is it'll just say, oh, I already have this information, survived, therefore I will predict they didn't survive, they survived, and won't look at anything else as much because it has the survived field. So we want to get rid of that for training purposes. But we want to keep that data, which we're going to call outcomes here because we're going to use that for training as the labels, as our validation. The next thing we're going to do is we're going to create an accuracy score, and we're going to use this to evaluate our model and how well it's running, which is this accuracy score function. It will take in the truth as well as the predicted values, and then it will use that to make a prediction. Right here, given the first, let's see. Yeah, so right here it's taking the predictions, and then it's saying, oh, currently we have a prediction accuracy of 60%. And we're going to be using this accuracy score later on to make our predictions. Okay. I'm sorry, I'm just caught up with the chat here. Sharma asks if you can take the deep learning nanodegree program in addition to this one, which starts in 2 weeks. With regards to that, my answer, and I'll post this in Slack because it says he's dropping off here. But with regards to that, the deep learning course assumes that you have a good understanding of machine learning already, just the high-level concepts. So if you feel like you have a decent understanding of it, by all means, you can take both classes. Otherwise, in order to take that class, really all you need to get through is the supervised learning and the model evaluation sections, and that should be enough information for you to get started on that course. The deep learning course does not go much into unsupervised learning or reinforcement learning from what I remember, unless they changed the curriculum for that course. So you should be fine so long as you complete up to that section, up until the end of the supervised learning section. And again, if you have to drop off at any point, this video will be I'll link the full video on YouTube in the Slack channel afterwards. I mean, we are getting close to time here, so I'll start speeding up the process here. Again, I highly recommend you go through this yourself. We're going on to making predictions now. So this right here shows an example of how to use the predictions function, which we'll be using for the rest of this section. So what it's saying here is, for all passengers, what happens if we predict everyone dies? Just 0 for everyone, 0 survival rate. How accurate would our model be? So we're going to go ahead and run that with Shift-Enter. And then for this first question, question 1, using the RMS Atenic data, how accurate would a prediction be that none of the passengers survived? So we're going to run the accuracy score method using the outcomes that we have, the truth table, and then passing in as well the predictions from this prediction 0 method, which we have assigned to predictions right at the end of that previous cell, at this highlighted part. So if I now run this cell, it says that if we predict that everyone dies, then we will have an accuracy of 61.62%. Okay. And I guess before I continue, are there any questions up to this point? Okay, just hurrying through here. Going to the next section. This right here is taking advantage of the visuals.py file script that's attached. So what we'll do here is we'll pass in our data, pass in our outcomes, whether or not people survived, and we'll take a look at one of the columns of the original data up here. We're going to take a look at the sex, male or female, and we're going to try to better visualize that so we can make better predictions. We run that cell, and it shows here that if we looked entirely at the males or females, where the left red bar is whether or not they did not survive, and the right bar is if they did survive, you can see here that regarding females, a lot more females survived than males did. If you were a male, there was a very high possibility that you were going to die. If you were a female, there was a very high possibility that you were going to live. Okay, so now using that information, we can then make a better prediction than just assuming everybody dies. So what we can do is for this same function above here, where they said, so this code is exactly the same as before. Prediction 0 is exactly the same as predictions 1, only where predictions 0 says predictions.append 0, predicting everybody dies. If we scroll down here, for predictions 1, it just says pass because they want you to put in your own code there. So what I'm going to do to save time here is I'm going to copy over this guy, the predictions append 0. And again, I highly recommend you do this on your own. But what we want to do is we want to use the gender of the passengers to make a prediction. So right here, what we're going to say is we're going to say if passenger, sex of the passenger, and taking a look back up at the original data up here. Again, sorry if I'm going fast. I'm just trying to get this done in time. Taking a look at the original data here, you see that sex is either male or female, all lowercase. These are both strings. and the data's already been cleaned, so we don't have to worry about typecase or anything like that. So if we say if the passenger is male, then we append to our predictions that they died. Else, they are female. We will predict that if they are female, they will live. I'm going to now run that cell using Shift Enter. And moving on to question 2, if you hit that Shift Enter on that print, it'll say your predictions have an accuracy of 78.68%. Comparing that to question 1, where we just simply predict that everybody dies, we will see that by taking gender into the equation, our model has become about 17% more accurate, 17%. All right. So let's say that we want to get more in depth with our visualization. And again, I highly recommend you take a look at the visuals.py script to take a look at how they're generating these functions. But we're going to use the survival stats method here, and we're going to run that. And now it's saying, given that the sex is male, what happens if we visualize the age? So what we're trying to do here is we're trying to get a more in-depth breakdown of the data itself to improve our ability to predict the outcome here. So we see here, looking at all the males, we see that if you were a male and if you were under 10 years old, there was a high chance that you would survive. You see that little green bar. In the background of it is the red bar for the same portion. So in the red, in the background is the number of men under the age of 10 who died. In the foreground is the number of men under the age of 10 who lived. Likewise, for the age bracket between 10 and 20, this dark green bar at the bottom is the number of men between the ages of 10 and 20 that died. And in the foreground is the number of men and women of men who lived between those ages. It's just dark green down here because the colors overlap. So you see up here between 0 and 10 is lighter green because they don't overlap. Between 10 and 20, this is red because it's not overlapping, because a lot more males between the age of 10 and 20 died than lived. So essentially, in a nutshell, what you can get from this is if you were a male between the ages of 0 and 10, there's a high possibility you lived. If you were any older, there was a high possibility you died. So the way we can write that, and what I'll do here is I'll pseudocode it first. If male and under 10, then live, else if male and over 10, then die. And we can go ahead and codify that. So if passenger sex male, if passenger age is greater than 10, then we predict that they die, else predict that they live. And I'll show you why I did it in this order in a second. So this here. Otherwise, they are female. And we're going to predict that if you're a female, you live. And we're going to use this for next prediction. Oh, that's right. All right. So we're going to see here, we're going to get an accuracy of 68.91%, right? Which is lower than 78.68%. So the reason why that is going back to what we were talking about at the beginning here, because of the entries that are not entered, that affects our outcome down here. So if we change the sign around to less than or equals to, change that to 1, to say that if you're less than or equal to the age of 10, we predict that you live, and otherwise you're over the age of 10, then we predict that you die. You run that, you'll see here that just all we did here was that we flipped the symbol from greater than to less than or equal to. And if we run this again, you'll see that jumps up by 11%. And that is because of the way that Python handles NAN. So what's happening here is all NAN values are being handled by this else case here. In the original case, it was misclassifying them. Now in this case, it's handling them properly. So that is one case where, if you're not familiar with the data, if the data was not properly cleaned, that would actually mess up the predictions and mess up the model. And again, I highly recommend you try this yourself. You try visualizing it, you try working through it to see what happens if you try handling that case differently. But that's essentially going on in the background, why flipping the sign from greater than 10 to less than or equals to 10 affects the accuracy so much. The next section here shows you different ways that you can actually visualize the data using the survival stats method. So you can pass in many parameters to it. So right here, they provide you with sex is equal to male if the age is less than 18. And let's say we want to look at over here, instead of age, we want to look at, and they provide some possible features right here: P class, sex, age, siblings, spouses, parents, and children. If we change this to, let's say, P class, and what this does here now is it says, given that the sex is male, given that the age is less than 18, we now want to visualize the P class method. And then remember, if P class is equal to 1, that means you're high class. If P class is equal to 3, then you're lower class. And looking at this visualization here, based off of the class, if you were in lower class, there is a much higher chance you would die than if you were in the either high class or middle class. So that would be one way to take a look at one direction you can go in next. They basically challenge you here to try out different methods. And I highly recommend you do this in your own time, as we're almost out of time here. But they highly recommend you try to obtain an outcome prediction accuracy of at least 80%. So mess around with this visualization to help you get an idea of where to go. So try using, like taking a look at siblings over here. If you want to add more breakdown into the visualization, you can say, oh, let's take a look at their gender, take a look at their age, and we could also say if P class is equal to lower class right here. We could take a look specifically at what happens with the siblings for lower class people. So we see here that if you're male, over or close to 18, and your lower class, there's a pretty high chance you would die. But if we change the age around to a lower age, now if you're a child under the age of 10, a male and lower class here, you see that so long as you were an only child or had no other siblings, there's a high chance you would live. versus if you had brothers and sisters, that would actually increase your chances of dying on the Titanic. So again, I highly recommend you mess around with this in your own time. Try to get your accuracy to at least 80% and share your results on Slack. See what you had to do to get there. All right, I'm just about out of time now. If you have any further questions, please message them in the Slack channel. If you're not familiar with the Slack channel, I'll go ahead and drag that into here just so you can see it. Give me just 1 second here. The Slack channel for this class is MLND session 840. Once again, I will link this video into the class. Other than that, your homework for today is to watch the Machine Learning Foundations lessons, and I will link all of these slides in the Slack channel as well. I also highly recommend you go through the scikit-learning documentation, as that will help you out with the future sections of the class. I highly recommend you go through the Titanic survivors data yourself. And finally, schedule a one-on-one session with me at some point this week. All right, that is all. Thank you very much for your time, and I look forward to working with all of you in the coming weeks. Thank you very much.